Okay, so sequence data allow for measuring or monitoring phenomena over time. Yeah, if it's time really, then we talk about time series, or because time series are more a specialization of general sequence data. So more generally speaking, in a given order of sequential events, of sequential observations. Yeah. So in that case, we have no concrete notion of time. Then we're speaking about general sequence data. Yeah. And some examples here for sequence data, we could have sequences of purchases. And the sequential pattern could be, well, customer buying A are likely to buy also B within the next 4 transactions. Yeah, so that is a more general pattern than the usual frequent pattern mining. If we look at just one snapshot without having these sequences of purchases of customers. Yeah, so we know that customer A bought that at this particular purchase, and then in the next purchase he or she bought something else and stuff like that. Yeah? So we have a sequence of the behavior of customers, of individual customers, and now we can use that to somehow enrich the patterns that we get. So one sequential pattern could be this enrichment of item set mining or even association rule mining by considering also the transactions the within transaction patterns, so to say, between or within one customer between the different transactions. When we're talking about time series data, so if we associate time stamps to these observations, to these features, to these sequences, then for example we could look at stock rates over time. Very, very appealing, very, very hard to do, but anyway, we could try to find stocks with similar behavior. So for example, they behave over the entire time frame similar, in maybe the hope that they somehow are related, and we can use the one of them to predict the other one, or the other way around, whatever. Or also just to find stocks that behave similar in a given sub-interval of time. Yeah, that could also be possible, of course. Yeah? So they are completely different patterns, as you see, and we can look at many different of these many different patterns. Yeah, so very, very application specific. Yeah, first of all, or at that time, not first of all, but at that time, a caution. Yeah, because sequence data is not streaming data. Sequence data is not a one-shot data stream. We talk about data streams in the lecture Big Data Management and Analytics. We also talk about how to analyze data streams, or how to process data streams actually. So sequence data is usually not considered to be data streams. Why is that the case? Well, in data streams, usually observations just come in over time. So there's also a time aspect, of course, like in sequences, but the income of the data, the velocity of the arrival of new data is usually quite high. Yeah, especially in e.g. that should read e.g. especially in real-time applications. Yeah, so the major challenge for data streams is that we usually cannot look at the entire stream history. Yeah, but we only have to work with a small part of the history, typically only with an aggregation of the history. So in other words, we just can access each data observation only once. When it comes in from the stream, we have to process it, we have to look at it, we have to decide about patterns or what, and then forget about it more. Not forget about it, but we cannot access it multiple times. Yeah, and we talked about the problems of data streams, as I said before, in the lecture on big data analytics, so big data management, big data analytics. So in that case, there are many different methods that we have to, or many different challenges that we have to solve, just because of this one-shot thing. Yeah, we can only access each observation once. And that is different usually in batch settings and also for sequence data. So for sequence data, we usually have a batch of data observations, even though now the data observations are not just one table, one snapshot, but are multiple snapshots, so sequences of tables or sequences of snapshots or whatever, but we still have a batch of those sequences. Yeah, so the sequences are now not really tables, but actually they can even consider to be tables. So there is not really a difference. Yeah, so if we just assume that the columns of a table are just the snapshots of the sequence, then we can even model sequences as tables. Yeah, and that means because we have a batch of those observations, we usually have access to the entire data multiple times. Yeah, so most of the classical data mining and machine learning algorithms require access to the entire data multiple times in order to learn some patterns. And we do have that here also in sequence data. And that is different. That is the basic difference to data streams, where we don't have this ability to access the entire data multiple times. Yeah? So just that you know, we are not talking about streams here. We are talking about sequence data where we still have access to the entire data set usually. Yeah. Yeah, so what is a sequence? A sequence typically has a length, which is denoted as n here, and the sequence is over a given domain, which is sometimes also called alphabet, and the sequence is nothing else than a mapping from the index set, in our case starting at 1 to n, and we map this index set to some elements from the domain, from the data type of the sequence, from the alphabet. So the sequence itself is a mapping here, is a function from the index set to the alphabet or to the domain. Yeah? And then there's some terminology which you probably know from other lectures here. So the set of all sequences of length n is O to the power of n, or O to the power of cardinality of the index set, which is the set of all mappings actually, all possible mappings from the index set to the domain. The set of all sequences over domain O is O to the power of star, or O star, just O star, which is the set of all mappings for any n, for any cardinality, for any length, so to say. Yeah, so O(n) or O to the power of n is the set of all sequences of length n, and if you don't restrict that the length, we're talking about O star here. Yeah? And of course, the sequences can be classified by their domain. So if the domain consists of categorical values, then or nominal values, then we're talking about alphabets, and well, you probably also know that from Java or any other object-oriented programming language that they are also called enumeration types in that case. Yeah. Well, if you have continuous values in the alphabet, in the domain, then we have real numbers, of course, in the observations. Yeah, and then O is not an alphabet, maybe in the common sense when we talk about alphabets, we talk about alphabets typically in the context of formal languages and theoretical informatics and stuff like that. Yeah. And from that, you probably also know these terminologies here. Well, usually in that case, you assume that the alphabet, the domain, of course, is fixed. Well, even if you have real numbers, we think that it's fixed, of course, but it's somehow categorical. Yeah, but in data mining and machine learning, of course, the domain, the alphabet, could be anything, and very often it's about real numbers. Yeah, so you have sequences over real numbers or whatever. Here are some examples. So text data can be viewed as sequences of any length, as you see, over some alphabets, some alphanumeric alphabets. So you have the characters and the numbers and maybe the special characters and whatever. Video data is a classical sequence data. The alphabet or the domain are the images. Yeah, so you have sequences over images in that case. Music data can also be viewed. So you see here that is a sequence over what is the alphabet, what is the domain. It's the domain of notes. Yeah, so you could think of music data in a special case as a sequence of notes. Yeah, and then from bioinformatics, you probably know protein sequences are sequences over amino acids, and gene sequences, for example, are sequences over nucleotides, and we typically have only 4 nucleotides, which are abbreviated by these 4 characters, C, G, A, T, for example. Yep. And then again, once again, time series are special cases of sequences where, the index set actually represents time slots. Yeah? So that is the basic difference between sequences and time series, that, or the specialization of time series. Then it's the same definition actually, but the index set now represents time slots, specific time instances. Yeah, and in the general case in sequences, that is not the case, obviously.